Welcome to the AWS Education Research Seminar Series. I'm Marcy Collinson, your session correspondent and the Scientific Research Programs Manager for the AWS research team. Today, we are delighted to have three presenters speaking about biomedical research in the cloud with the NIH STRIDES initiative. Our first presenter will be Dr. Susan Gregorek, who is the Associate Director for Data Science and Director of the Office of Data Science Strategy at the National Institutes of Health. After Susan, we will have Dr. Ankit Malhotra, who is the Senior Technical Business Development Manager at AWS. And then we will hear from Dr. Joel Lipkin, who is the Chief Operating Officer at 4 Points Technology. We will reserve the last 5 to 10 minutes of the session for a Q&A portion, but please feel free to place any questions that you may have during the presentation in the questions queue in the GoToWebinar toolbar, and we will read them aloud later on. So without further ado, I'll pass the microphone over to Susan. Susan, please take it away.
Thank you so much, Marcy, and thank you, AWS and team, for inviting myself and my colleagues from the National Institutes of Health to talk about our exciting programs and STRIDES and how we're using these to really deliver on biomedical research. So as you may know, the STRIDES program aims to develop state-of-the-art data storage and computational capabilities through partnerships with commercial cloud providers and other commercial providers. In addition, we offer training and education for researchers and innovative technologies such as artificial intelligence and machine learning and optimization of workflows. I'll tell you about each of these during our time together today. This is part of a larger program, our strategic plan for data science. So what I'm talking about is just one small box in our large data ecosystem of activities, and this is our data infrastructure, optimized data storage and security. There are a number of other activities that we're doing, and some of these are impacted by the work we do with STRIDES, such as connecting NIH data systems or modernizing our data repository ecosystem and storage of individual and large data sets. So as we go through the work that we do with STRIDES, I'll highlight some of these other activities as well, and then I'll end on other highlights that we've accomplished within the last few months through our data science strategic plan. Why are we interested in STRIDES? There are many benefits to researchers and to NIH. For research programs, there are significant savings that you can have on storage and compute in the cloud, as well as additional services such as training and analytics pipeline. Some of these professional services are engagements such as consultant work and work that will develop cooperative programs in the cloud computing environment, such as AWS. And finally, a number of training opportunities, such as standard introductory content, as well as content that's optimized for biomedical research. Both of these trainings have been in person and online, and since COVID, all of the training is virtual only. There are benefits to NIH. For example, we see additional data protections by securely storing and serving our data, taking advantage of modern cybersecurity capabilities and audit and logging trails. We're able to connect our data resources and our data sets in a cloud environment in new and innovative ways by taking advantage of STRIDES. And finally, in an unprecedented capability, we can now gain insight into the cost and usage of data sets so we can see how researchers are utilizing or reusing data and how best to optimize our workflow and our pipeline or our offerings to benefit our researchers. STRIDES has hit a number of significant milestones in the past few months. With 17 NIH institutes and centers participating, we've been able to bring 246 programs or projects on board to STRIDES. In addition, 36 academic institutions, medical centers, are participating in STRIDES. And with all of this, we've trained over 1,800 graduate students, postdoctoral fellows, senior investigators, as well as NIH investigators and staff. Through STRIDES and through AWS and our partnership, we have stored 80 petabytes of biomedical data in the cloud. This is an unprecedented amount of biomedical data available for researchers to compute on. I'll show you a few examples of some of the work that we've done with this data. In addition, Researchers have utilized AWS and our other STRIDES partners for 30 million compute hours. This results in a savings of approximately 8.5 million, and that's money that saves our taxpayers and can be reinvested into new data science or new analytical capabilities. There are 3 different ways in which we participate with STRIDES and AWS. The first is through an institute who has a very particular program. I'm going to show you examples from our TopMed program that's instantiated through the Biodata Catalyst. The IC then manages and supports these programs, working directly with our STRIDES team and our cloud service providers. In addition, I support a number of NIH shared technologies through my Office of Data Science Strategy, such as a unified NIH identity and access management system that I'll describe in a minute. Many institutes and centers and researchers out in academia and medical schools work directly with our cloud service partners and providers through, for example, our cloud resellers to develop their computational storage and database needs directly. As a researcher, how will you engage with STRIDES? Well, we have a number of training opportunities and learning opportunities where you as a researcher can decide on the best cloud platform that suits your research based on features and cost and other factors. By providing your funding or co-funding documentation, you can get access to STRIDES through your institution. You can receive your access to the managed cloud environment of your choice, construct, your architect, and configure your resources for storage and compute, and to support your research needs. In addition, you can also get direct technical help and troubleshooting, as well as optimization for some of your workflows and pipelines. And the ultimate goal, of course, is to make research discoverable, to make data shareable, and to publish our findings in scientific journals and papers and conferences. So that's STRIDES in a brief nutshell, but what I want to tell you about now is how we use STRIDES, our success stories for making research greater than the sum of its parts. Some of our use cases that we have worked with STRIDES on include, for example, childhood oncology and childhood cancer. In order to solve this pressing use case, it requires a number of data and resources, and those data are not necessarily in one particular platform. As a researcher trying to understand childhood cancer, you will certainly want to gather data and tools from our Gabrielle Miller Kids First platform, but you will also need some data from our Cancer Moonshot or our Cancer Commons Research Framework. Most likely, you're going to need to have additional data from GTEx, potentially even the TopMed data set from Biodata Catalyst. Maybe eventually, you'll need additional data from all of us. So the message here is that many of our platforms have been developed by institutes and centers to serve very particular research questions, but questions that researchers have could span many of these platforms. And so when we think about creating an infrastructure that leverages our platforms and our technologies, we really have to create an infrastructure that's interconnected in ways that are unprecedented. I'm going to tell you about a use case that involves the 4 platforms, Biodata Catalyst, the Cancer Commons Research Data Commons, the NHGRI Anvil, and the Kids First, solving that precision oncology question for childhood cancer. The first step in this is to create a researcher user authentication system. It's a unified, efficient, and effective secure authorization and authentication service that will streamline access by researchers to NIH-funded resources, allowing you to log in once and get access to the data that you need for your research. So this is the system as it was last year, I think, when I came and spoke. Researchers who wanted to ask questions between, for example, the Anvil and the Cancer Commons Research Framework would have to have separate logins for each of these systems and separate authorizations for each of the data that's held in these systems. So in a sense, researchers would need to log in at least 5 times just to do one workflow. As of this month, our researcher authentication service is in production mode in CIT in partnership with STRIDES and available both on AWS and Google for any of our 4 platforms that will allow you to log in once, through tokenization and passport system, you'll have access to your data on these 4 systems that are in our phase 1 rollout. You can then get the data that you're interested in across these systems and compute and then share your data. So although it seems like it's a small step, it's a step forward that really helps researchers look across our different platforms, get the data that you're interested in, and then be able to compute on it. This would not have been easy if it weren't for AWS and our STRIDES partnerships. Having these platforms in the cloud, providing access to data to researchers really makes this next step possible. And what will we do next? Well, certainly broad search across all of our data sources, aggregating data and computing on it is a goal. Let me tell you about a few of our success stories. So for example, there's the TopMed, the omics precision medicine genomics data. This data is a variety of diverse data from different participants. All of the data through the Biodata Catalyst Consortium is now cloud-based, providing researchers tools and applications and workflows. We are providing this data in a centralized location in the cloud where researchers can access this data and then reuse it. One of the benefits of STRIDES isn't just storing this data on the cloud, but also to enhance the workflows and the pipelines that make the analysis of this data possible. So through the TopMed imputation server, we've been able to move the data to the cloud and optimize the pipeline for data processing that would have normally take about 12 months into just a couple months. So STRIDES makes this possible not only by providing favorable pricing, but also by providing excellent engineering support systems. And I'm very, very grateful for the work that AWS and our STRIDES program have done to really enable these types of computational workflow optimizations in the cloud. I want to tell you about another success story and one that I work on pretty closely with our NCBI NLM Institute. We've moved over 36 petabytes of public and controlled access of the sequence read archive into Amazon Web Services, as well as our other STRIDES cloud platforms. This is a fairly large amount of data. We've been able to optimize the storage of this data, partitioning it between the hot active storage and the cold storage, so that researchers can look across the entire compendium of SRA, find the data that they're interested in, and if they need to, thaw that data out for their analysis and do their analysis within the cloud AWS platform. The ability to dynamically move data between hot and cold storage for NIH saves us a tremendous amount of money, and it makes that data available in a sustainable way. And this is something that we're really thinking about, is sustaining data resources for the long term. This is certainly going to be important, not just for the sequence read archive, but for all the data that we are and will generate to address COVID-19. Again, the ability to store these data sets, provide central location for access, and availability for compute resources on this data is one of the goals of STRIDES, and certainly AWS is making that a reality. What have we done with this data? I want to tell you about one success story. It's the story of analyzing over 10 years of data collected by the global research community from coronavirus. So every coronavirus that's been sequenced and is housed in the sequence read archive is aggregated. It's a lot of data. It's a lot of petabytes of a sequence. Siratus has created a workflow on AWS that will allow you an all-to-all sequence alignment comparison of this data through their workflow and pipelines. They were able to compress 12 plus months of alignment of the sequence to 3 to 4 days. It's incredibly important as we move forward with addressing COVID-19 to be able to track the evolution of those COVID sequences throughout the pandemic. And so identifying tens of thousands of coronavirus or coronavirus-like sequences through the alignment is made possible directly because of the benefit of AWS and the STRIDES program. In addition to those success stories, we have and we will continue to reach out to train you, researchers, where you are right now virtually. We've trained and done a number of trainings at Columbia University, all the way to the University of Nevada, Las Vegas. We're planning additional training opportunities from Stanford to Tulane University. So across the country, from Ivy League schools to schools in idea states, we intend to reach you where you are and to help you utilize our STRIDES program, AWS, and our STRIDES partners to the best of our abilities to enable your research. What are our plans? We are launching a national campaign to onboard more than 100 academic institutions and medical schools and centers. We are testing alternative models for training, particularly now that we are all virtual. In addition, we're testing new ways to instantiate workflows, optimize those workflows across cloud, utilizing different types of cloud environments and different types of platforms. I hope that you will continue to watch our STRIDES program as we initiate new partnerships for STRIDES. And so do stay tuned to the work that we will do and to the success that we hope to have to enable researchers to utilize data in unprecedented scales. Just a quick highlight for the other activities that my office is involved in. I did mention a little bit about our new model for very large scale data storage, and this is data storage on the 80 petabyte range and how we're going to manage that in a cloud environment. We also support researchers who have databases or knowledge bases as digital resources through 2 funding announcements. These are NIH Biomedical Data Repositories and Knowledge Bases. We have completed a pilot to instantiate fair data sharing through a generalist repository, and now we are looking to enhance metadata sharing across different platforms. We have a number of training opportunities for researchers to come and work at NIH. If you're an undergraduate, you might be interested in our Civic Digital Fellowship. And if you're a researcher from academia or industry, we have a senior level data scholars program. Our first cohort will start in October. And we continue to engage our community with a number of different codeathons for software development. And we're planning new activities across the portfolio of NIH, from tribal communities to HBCUs to large-scale medical and academic institutions. And with that, I am going to now pass the ball over to my colleague. So, Dr. Malahorta, I am passing the ball to you.
Thanks, Susan, and thanks for the great overview of the STRIDES program. It's really great to see how we are expanding in a close partnership with the NIH. Today, I wanted to talk about how AWS is helping transform biomedical research, working with the researchers and working with the funding agencies. I'm the biomedical and life science lead for the AWS research team, and obviously, within a space of 20 minutes, we cannot cover all of our services, all of our case success stories, but I would love to give everybody who's attending a flavor of what we are doing at AWS. So let's start the journey. It all starts off with something that I think everybody here is aware of, the scientific method. It starts off with asking a question, generating a hypothesis, doing experiments, generating results, using results to refine the model, and finally asking a new question. And round and round we go as scientific researchers around the world. How does AWS help with this process? And that's highlighted in green in that particular slide. AWS provides access to critical data sets that are essential for generating hypotheses. We also provide services that allow researchers to automate and accelerate the process of experimentation and make it repeatable. Something that is critical for replication and reuse of data and workflows. We also provide mechanisms for researchers to easily share results, whether they're workflows, whether they're data with the biomedical community. And perhaps most importantly, we engage with the researchers directly and provide access to our state-of-the-art analytical capabilities to allow them to innovate. All of this is moving towards addressing several challenges that are facing biomedical research today. Our data is growing at an exponential scale, and it's just getting faster and faster with the most recent sequencing technologies and other technologies that are coming to the fore. Our research model, even today, is extremely siloed. We work in our labs, we work within our universities, whereas true research these days is moving to a much more collaborative model. Most of the places that research is happening is still on-prem resource bound. We are limited to what we can do on premises, and this is something that is a critical thing that we would like to solve with the cloud computing platforms. And finally, there's a crisis of reproducibility. There's a lack of consistent standards and workflows, and there are initiatives that we are developing to help with that as well. Finally gets to how does AWS really help with research. We want researchers to think about science and not to have to worry about service. We want to enable researchers to collaborate, to provide access to data sets and allow them to share data sets across institutions. We want to easily enable them to share their efforts, developing workflows. We want to improve how research can be made more reproducible, and then obviously state-of-the-art machine learning analytics and the security framework that is sort of job zero at Amazon. It all starts off with our global footprint. As of today, AWS is present in 24 different geographic regions around the world, comprising of 77 different availability zones. Think of availability zones as that foundational framework that provides resilience and reliability. So each geographical region has multiple availability zones, and each of these availability zones is one or more unique data centers that all come together to make this foundational architecture that provides researchers the ability to collaborate across the world, share data, and work with around the world, and get that reliability and resilience that is central need. I did mention it's about science and not service, but if you talk to that researcher, you talk to that graduate student or postdoc who's trying to meet that deadline and is waiting in queue at a university, sometimes it is about service. And this is where we should talk about the broad set of compute instance types that Amazon provides across general purpose, compute optimized, memory optimized, accelerated computing, GPU instances, and storage optimized resources. We provide researchers with a broad menu of compute options that they can tailor to their needs. And the idea behind all of this is to make the concept of a compute cluster elastic, so that you can scale the cluster that you're working on in the cloud depending on the needs that you have. So perhaps in the morning you're starting out, you're just prototyping some code, you have a small cluster that you're working on. Sometime in the afternoon you feel like you've reached production and you want to go ahead and analyze multiple data sets. So you increase the size of your cluster. And then you want to sit back with a coffee and analyze your results. So yeah, you put the compute cluster away. That scaling behavior can be done manually, or you can also do it in an auto-scaling fashion so that the platform scales as the demand the need goes up and down. We also, with AWS, the compute clusters, because of our diverse menu of compute options, the clusters can be fit for purpose. In the morning, you can have an analysis cluster that's processing all the weather data and generating insights. And then you switch over to a GPU cluster for visualization. And then obviously the clusters are ephemeral. So when the need goes away, you clear up all of the clusters that you have, you put the data back in S3, and you analyze. This is one example of the strength of the AWS and the cloud computing platform. This is one example of that happened in 2019. It's an example of the largest cloud simulation in history, in which over 51,500 GPUs were put together in a single compute over a 2-hour experimental time. And at the maximum, at the peak, the compute environment reached about 380 petaflops, or about 95% of the performance of the best HPC cluster that's out there. Let's talk about some of the other impediments to research, to collaboration, and this is data silos. So one of the biggest hurdles that we have that hurts scientific collaboration is access to data. And this is where AWS solutions can help lift those barriers and allow us to accelerate and democratize research. We have a whole multitude of storage options between Elastic Block Store, Simple Storage Service, and the Elastic File System. And more recently, the Amazon FSx for Lustre. And this is something that I would like to talk about today. The Lustre side, my slide went back. Let me go back. So FSx for Lustre is designed for high performance workloads. The Lustre file system provides throughput up to hundreds of gigabytes per second and millions of IOPS. It provides a consistent sub-millisecond latencies. It has a tight integration with the S3, and it allows for lower economies of scale, so you can drive your costs down. Another important component of the sharing and allowing collaboration is the AWS Open Dataset program, available at the Registry of Open Data on AWS. The Open Dataset program covers the cost of storage for publicly available high-value cloud-optimized datasets, and we work with the data providers who are seeking to democratize access to datasets, develop new cloud-native techniques and formats to allow people to work with the data, and encourage the development of these biomedical research communities around various datasets. At last count, there were about 178 different datasets that were hosted on AWS S3 as part of this program. By bringing the focus back into the biomedical domain, we have 54 different datasets, about 8.5 petabytes of storage that is available. And they span many different projects you might have heard of, whether it's the Pangenomics project, the Microbiome project, 1,000 Genomes, ENCODE, TCGA, or Gabriela Miller-Pitts, for something that Dr. Susan also mentioned in her talk. One of the example use case where this is important was the project that was done with UCSC and the Chan Zuckerberg Initiative, in which they wanted to accelerate the process of long-read genome assembly. So they created a tool called Shasta, which is an open source toolkit for assembling genomes. As currently implemented, Shasta can produce draft human genome assembly in about 5 hours using a single compute instance, one of our larger ones. And it beats other competing software tools for genome assembly. And all this comes at a cost of only about $20 if you are using the AWS spot market or reserve prices. Another impediment to collaboration is our crisis of reproducibility. Back in 2016, in a paper published in Nature, researchers asked other researchers. They polled about 1,500 researchers, and they asked them whether they think that there is a crisis of reproducibility, and about 90% of those researchers agreed. And this is where I think we need to, as a community, move towards better putting our workflows together, versioning them. And one solution that drives us towards that is containerization. AWS provides a whole landscape of container services, starting off with the container registry, the Amazon Elastic Container Registry ECR, that allows people to look and share their containers. These can be hosted either using Amazon EC2 or you can use a fully managed service such as AWS Fargate. Finally, the management, the deployment, scheduling, scaling of the containerized applications can be done using either the Amazon Elastic Container Service ECS or using Kubernetes with the Amazon Elastic Kubernetes Service. How do you do compute using containers? Amazon has AWS Batch, which is a managed service for container-based jobs. Each job is a Docker container with runtime parameters, and we submit these jobs to a queue with priorities, and we let the Amazon Batch containerization service take care of it. You don't need to install any servers to manage this. AWS Batch provisions, manages, and scales the infrastructure needed to run the jobs. You can also choose to do cost optimization on top of it, using spot instances or reserved instances to get the most research possible out of your project. We have several different workflow orchestration options as well. AWS native, which is AWS step functions that allow you to construct those workflows and then pass them on to Batch to run the workflows, finally writing the data back to S3. We also support Cromwell and Nextflow, third-party open source and popular workflow orchestration options, and that's something that you can use with AWS Batch as well. So I've gone through very quickly with various services that Amazon provides for biomedical research, and I encourage people to look through them and reach out when they have questions. Let's quickly look at a few success stories as well. One success story was enabled through our partner Ronin, which provides a platform for project management and getting access to compute through easy to understand project views and budget control and management. As part of a research project, researchers at the University of Adelaide wanted to analyze basically whole barley genomes, wheat genomes, and to try to understand what was happening. To increase the compute capacity and scalability, the researchers worked with Ronin to create a new HPC cluster based on AWS. And using that particular cluster, they were able to analyze the 3 terabytes of the exome and genome data in about 6 hours, and which would have taken them about more than 2 weeks to complete on a local infrastructure. Another particular success story was our partnership with Adequate Genome and Illumina in analyzing the fastest ever analysis of 1,000 pediatric genomes, whole genomes, using Amazon EC2 F1 instances. All of this 1,000 data sets we were able to analyze all of the data in under 2 hours and 25 minutes. And this is now available through Illumina's Dragon Genome pipeline, which is now using EC2 F1 instance. It runs on AWS. Another success story close to home was the Fred Hutch human microbiome research that was done last year, I believe. Fred Hutch Microbiome Research Initiative, a team of researchers that engaged in the analysis of the microbiome, wanted to study the microbiomes to manipulate them and make therapeutic cancer drugs more effective. To support their efforts, they wanted to analyze and process a large number of whole genome data sets. They chose Amazon Web Services to create the high HPC platform to run the microbiome analysis. And they use Nextflow framework to orchestrate AWS Batch processes to accelerate the processing time. The organization was able to do all of their analysis using Amazon EC2 instances powered by Intel Xeon Platinum 8000 series processors. And it basically reduced the 7 years of compute time that would have taken to analyze 15,000 different biological samples down from 7 years to 7 days. This enables collaboration with other scientific researchers. This enables researchers to move fast and quickly use the analysis to ask more and more, generate more hypotheses and ask more questions. How do you engage with AWS for biomedical research? We encourage people to reach out to the AWS research and technical computing team. And yeah, thanks. I'll pass on the control to Dr. Joe Little.
So far, you've heard a lot about how the Strides initiative is focused on using the cloud, and you've gotten a very good sense of how the AWS services can be used to support biomedical research. What I'm going to be talking about is the offering of AWS within the Strides initiative and how to onboard into the Strides community if you are a biomedical researcher with an interest in using the AWS cloud. I'll be covering what AWS offers through the Strides initiative and the contracting processes for onboarding with Strides, and then finally the AWS and 4 points of contact for going forward to do that. 4 Points Technology has been working with Amazon since 2012, and our focus is very much on the organizational and operational side of using the cloud. So we coordinate very closely with Amazon's technical resources, subject matter experts, and account teams to work with the Strides program, work with individual researchers and institutions. What 4 Points offers through the NIH Strides initiatives is essentially 4 things. First of all, and probably it gets the most focus, is easy contractual access to AWS cloud capacity, the 200 plus services that Amazon offers. And we do it at a significantly discounted price and with some very special features that are useful for sharing and maximizing the value of data throughout the community, including a special content distribution capability of Amazon called CloudFront, and a waiver of most data egress charges, so that the getting data out of AWS for analysis is the cost is minimized. And a very special feature, Amazon offers different levels of support for the cloud. The highest level is called enterprise support. And through collaboration between the Strides program and Amazon, we're able to offer enterprise level support, which includes technical account managers and accelerated service and support at a subsidized rate. So the net cloud is easily accessible. All of cloud resources are available to you as a researcher at an easy to contract discounted rate. In addition to cloud capacity, cloud utilization, the Strides initiative includes access to training, and this is both technical and biomedically focused training that AWS offers through their training organization. Again, it's discounted and subsidized by the Strides program. And AWS also offers free training sessions continuously online. So the capacity to give you access to training, access to the cloud, training to inculcate best practices and the like, and also access to the AWS ProServe community. These are subject matter specialists that AWS deploys on a fee basis to users to accelerate their adoption of the cloud, and they are highly technical, highly skilled subject matter experts with a strong grounding in biomedical research in many cases. And again, through the Strides contract, this is a discounted offering. And finally, the fourth element of the Strides program is the public data set program. AWS has made a significant multi-petabyte commitment to NIH that data sets which are in high value and generally used throughout the community will be placed in AWS cloud storage for free at no cost, and these are available throughout the Strides community for additional research. And 4Point's job and AWS's job is to assist you as you're looking at the Strides program to come up with which of these all options or all of these options are best suited to your needs, and to work with you to make them available as quickly as possible. Onboarding is a little bit different for extramural researchers versus the intramural community. For extramural researchers, it's very much a two-step process. First of all, establishing a business relationship between 4Points as the contractor and your institution, your medical school, your university. And then once that's completed, aligning your utilization of the cloud, your AWS accounts with the Strides program, which we call onboarding. To join the Strides program, a good place to start is to ask whether your institution is already using AWS and whether you're already using Amazon Web Services. For users, and AWS is highly distributed, obviously, throughout the research community. For researchers who are already using Strides, one of the benefits of the Strides program is that there's no need to change up your existing enterprise agreement or redo your BAA. The Strides program allows you to take advantage of all that work that you've done previously and just bring that over under the Strides initiative. We also, 4Points and Amazon, work with you to better understand your governance environment, whether you are part of your university's overall AWS structure, whether you use organizations, what are your billing and reporting requirements, and we tailor how we onboard you to that existing governance structure. And for universities who are already working with an existing reseller, we're developing programs to work with your existing reseller if that's what is easiest for you as an institution. And if you're new to AWS, completely new to AWS, we can obviously help you establish the relationship, set up your accounts, provide advice on basic security and reporting requirements. And there's the link to the NIH Strides initiative is a microsite that gives you more information about onboarding and also gives you a simple sign up to receive more information from 4 Points. And if there's one bit of advice I have, if you're interested in the STRIDES program and what you've heard, work with your Office of Sponsored Research, your finance organization, or your IT department up front, so that we can coordinate the overall enrollment and onboarding processes very quickly. And then if you're an intramural researcher, it's a 3-step process. It's, first of all, reach out to the STRIDES program office, validate that your workloads are in scope. The point here is that STRIDES is focused on research versus administrative workloads, and particularly within NIH, the distinction is important, and 4 Points and the STRIDES initiative can support research programs. And then once that's completed, we as an organization can either transfer individual Amazon accounts under the STRIDES initiative, or we can transfer entire master payer accounts under the STRIDES initiative, so that you can keep your controls and governance at the individual institute level in place. 4 Points very much focuses, whether you're intramural or extramural, on the billing and reporting side of the equation, and we'll work with you to make sure that we retain everything that you need in terms of visibility and transparency. And final point, and I think Susan touched on it briefly, within NIH, STRIDES is developing an authority to operate for the NIH cloud environment, which is going to make it much, much easier for new workloads to move into the cloud across NIH. And all NIH will be able to leverage an existing ATO and governance and security plans around the program. And so for more information, you can reach out to the AWS STRIDES team or the 4 Point STRIDES team, or both. We work closely together every day. We have a dedicated team. Amazon has a dedicated team supporting STRIDES, and we're seeing great success and great feedback from the users who have moved into the program, and hope we can provide you with more information going forward. Thank you.
Wonderful. Thank you all. What a wonderful presentation. We have a rather inquisitive audience, so I'm going to jump right into questions. I think the first one must be pointed at Joel. So it asks, are the savings sustainable?
Absolutely. The STRIDES is a multi-year program, and 4 Points has committed to discount programs with NIH through STRIDES that will continue for the life of the program at a minimum. And additionally, I know STRIDES is looking at the upcoming fiscal year and their plans to continue supporting the extramural program financially.
Great. Okay, next question says, excellent topic, so that's good. Do you provide computational time supercomputer for computational biowork?
That perhaps may be directed to me. We, in our intramural program, we have a lightweight supercomputer called BioWolf for our intramural researchers and their collaborators. For the extramural community, the primary research use is either through the DOE Insights program that gives you computing resources to unprecedented scales through a number of DOE facilities, or through the TAC, the Texas Advanced Computing Resource at NSF. NIH does not have its own supercomputing resource, so we have to partner with our other agencies to provide those resources. Those are usually facilitated through grant funding.
Wonderful, thanks, Susan. Next question is, do you find that you need to do additional manipulations to the data to provide cross-resource access, or is the data already in a uniform format across these resources?
I think that might be somewhat to me and maybe also to ANCAT. So, well, yeah, in a perfect world, it would be already harmonized and ready to go out of the box, but that is not the situation that we live in. And particularly for COVID, we are now working aggressively to leverage technologies such as FHIR, Fast Healthcare Interoperable Resources, in order to create a resource that will provide a mapping between the different types of data models. We're also looking to unify common data elements across at least our COVID system so that we can get to that level of harmonization. But there is a significant amount of time and effort spent on data harmonization. And right now, the Cancer Institute has stood up a data harmonization center, acknowledging that this is a significant amount of work.
Yeah, and
Great.
I would just, on what Susan just said, data harmonization and standardization is probably the biggest lift effort that we need today to enable these data commons to be easily searchable and indexable. So, and that's a high priority for Amazon as well.
Yeah, there must be some great technologies and methods out there in AI, and the research community can help us with this. We
Absolutely.
benefit.
I would encourage people to reach out, and there's several cases that we can talk about.
Mm-hmm.
Great, thank you both. Next question is TopMed imputation server accessible to the researcher for a given period after successful registration? Awesome opportunity it is.
Thank you. Yes, it is available. You will have to go through the data access process. That can take some time through NHLBI, but afterwards you will be able to access the data, and it's compute ready on AWS as Kat said. So indeed, and I think that I don't believe it's time limited once you have access.
Yeah, agreed. Yeah, absolutely.
Great. Okay, can we query the SRA data on AWS? If yes, how? Is there an API?
This might be a joint question as well. So the answer is yes, sort of. Go ahead, Ankat. You might know a little more.
And we are working on improving that. But currently, the way that you get to the entirety of the SRA is through the NCBI's SRA toolkit. And they have AMIs available for you to be able to access the SRA data. For the data that is available through the Open Dataset program, which is a subset of that data currently, you can also look for that through the registry of Open Dataset on AWS. And Susan, unless I missed something.
Yeah, so I'd say that in addition, a grand challenge that we're bringing a data scholar to NIH to solve is how do you search and query across 32 petabytes of data? I think that in itself is a grand challenge. So there's a lot of research opportunities here, and partnering with AWS is going to help us solve these compelling questions.
Wonderful. Next one is, how is access to DNA Nexus work through RAS login?
That might be for me. Okay, so I might be missing something, but as far as I know, DNA Nexus is not part of the phase 1 RAS login system. But we are in phase 2 working to bring in the in-commons so that you can log in via your university credentialing system through multi-factor authentication. But right now, as far as I know, DNA Nexus is not part of phase 1.
Okay, great. We have a long one here, so I'm going to read through it quickly. This is Dr. Vijay Nagarajan from the Mole Bio Cloud. We were one of the 9 vendors that worked with the NIH Commons Cloud pilot initiative. Congrats to Dr. Susan Gregorick on the awesome achievements in a short time. We often have questions from NIH researchers about how they could use our AWS DOS platform that is available on AWS Marketplace. Could you please provide any pointers on this? Thanks in advance.
I might also have to call a friend from AWS, but I believe that if it's part of the STRIDES program, should be accessible.
Yeah, and it might be something that I need to look into also. I'm not quite familiar with the DOS's platform, but it should be accessible through the STRIDES initiative. If you reach out to the email contact that we have for the AWS STRIDES team, we can definitely figure that out.
Great. And I'm going to just pick one more because we're running out of time, but we have one that says, NSF Exceed has similar concepts. Just curious if you have some collaboration with NSF computing platforms.
Can you restate that?
Sure. It says NSF Exceed has similar concepts. Just curious if you have some collaboration with NSF computing platforms.
Yeah, so we have a loose collaboration and a somewhat stronger collaboration for PI research. So I do sit on the advisory board, so I am familiar with what Exceed is up to, but we do not have a strong partnership in providing computing resources across the federal government. However, we have a new partnership with NSF to fund computer science PIs to develop biomedical capabilities, particularly in data science and AI, that will be forwarding in FY21. So although we may not fund the infrastructure, we will be funding the PIs.
Yeah,
Great.
and just
go
to
ahead.
build on that, Marcy, thank you for sharing the link to the seminar series. But if you can share the link to our AWS research team as well. We have experts on the research team, and we are, just like we engage with the NIH, we're very closely engaged with the NSF as well, and working together with them.
Wonderful. I was going to say the same thing. So yes, I'll put our homepage in there as well. I did go ahead and put our seminar alias in there. So apologies if we did not get to your questions, but feel free to email that alias with any additional questions you may have, and we'll make sure that we get an answer from you from the correct party. I also put a link to our series homepage in there, where you can find additional information about past sessions as well as upcoming sessions. Our next session will be part of our Research IT training series and will be about serverless Jupyter on AWS, fully managed notebook environments. That will be with Dr. Zhenjun Zhu, who is a Senior Solutions Architect and Software Executive in Higher Education at AWS, and will be held on September 16th from 9 o'clock to 10 o'clock a.m. Pacific Standard Time. So please be sure to register when you see that come through your email. And we want to thank everybody for joining us today, and we look forward to seeing you again soon. So have a wonderful day.